Probably for next 20 minutes, I will just go very high level on the topic called defending against the unknown. And of course, software-defined secure network could be one of the solutions to address or some direction towards how can we probably reduce the risk of some of the unknown risk actually. So I'll be largely focusing around that. So I will touch upon what is really happening in the industry, not just specific to security, but as a networking or information technology sector at the generally high level thing. And then we'll look at what is really happening in the security vendor landscape or security solutions landscape, because we come from the solution community. We have heard from Parag about what is really happening in the world and what kind of attack vectors and indications that we are receiving. And then I will go into certain solution aspects. I must admit that there is no single solution which will solve all the issues, because the very thing which talks about unknown, if it's unknown to everybody, not just me, but to many people. That means your solution will be largely focusing on how far you can go and create certain ecosystem to ensure that at least you have the ability to mitigate is much higher. I think that's where we are attempting to. So a few things which are happening in the industry, and we kind of split it into two horizons, the horizon 1 and 2. Horizon 1 is, as we speak, for maybe next 2 years, is that this is a common thing that all of us know, and we are all, I think many of our enterprises and companies are living through that. Applications move to public or private cloud. In certain sectors, it may move a little later, but many sectors have moved maybe some non-critical, semi-critical, or critical applications to the cloud. And 34% of aggregate growth in cloud data center workloads, 14 to 17. That means a lot of people are adopting cloud as a technology. The other key thing that we're seeing is when you move your assets to the cloud, you should have enough mechanism to access the cloud. Because the user experience, if your data center is hosted in your own local area network, probably you have a better access, better performance, better latency parameters, better control. But the moment the information assets are moved to a place which is probably you don't know, it may be somewhere in the network, somewhere in the cloud, and how much of access bandwidth is coming in. So that means your bandwidth requirement, the notion of wide area links will really change. For example, in our own case, we are hosting our sales forecasting tool, some of the learning management tools, our entire messaging system, our multimedia system, all in the cloud. Now, if I have to access it from my mobile phone, I don't have to go to my corporate VPN exit point in Bangalore or in Hong Kong or in California. That will be a great big tax on the network to take all the way up to that place, and then from there you actually divert the traffic into the individual cloud providers. But the requirement will be that can I branch out at my exit point, maybe an Airtel gateway or a Jio gateway or a service provider gateway, can I really traffic? So what essentially is doing is your traffic patterns are changing. Because your assets are moved to cloud, you can't always say that your traffic is always traveling this path. It is actually getting to the closest way you can reach consume the information which is hosted in the cloud. So there's a change. I think many of you may be in the process of renovating your branch network. If you are in the financial sector, there is a notion of software-defined wide area network. The whole purpose of software-defined network is to address one of the problems, like the wide area traffic patterns are changing. The other thing is investment in perimeter security is increasing, because all of us know actually that perimeter security and perimeter firewall is kind of a standard design that we use. But in the horizon 1, we see that investment will go high. Maybe the complexity of the device may increase, the scale may increase, because most of the time the perimeter firewall become your bottleneck. In the past decade, your wide area network, wide area link bandwidth could be a bottleneck. Then coupled with that is the scalability of your perimeter security, because those are the two weakest part, not from the security point of view, from the performance point of view. So, but I have seen certain large electronic commerce vendors doing away with the perimeter security at all, because that becomes the biggest bottleneck. If they have to really scale based on seasonal loads, do I still need a firewall, which is a bottleneck, or do I put a 10x capacity on the firewall and leave it for the full year, which may not be utilized? So in the horizon 2, when you jump into horizon 2, 3 to 5 years, enterprise adopt a cloud first strategy. It means you will first think that can I host it in the cloud first? And the question will be, why should I host in my premises? That will be the question that you ask. Today you ask, why should I host it in the cloud? But then it become a cloud native system. And LAN becomes, look at the local area network in your enterprises, that become a ramp to cloud. Because your assets are hosted in the cloud, the local area network, that means a lot actually. As network designers, that means a lot. The way you design your local area network will radically change to adapt to the cloud systems. And then it will also shift to securing users and applications in the cloud. The securing your enterprise local network versus enterprising your assets in the cloud. And of course, a cloud managed secure enterprise connectivity. I've talked about software defined wide area network, because can I really dispense your wide area network from the cloud? Today it is like you have a regional office. If you are in a large BFSI kind of a setup, you have branches, you have regional officers, you have headquarters or data center, disaster recovery or near data center. That's the way the hierarchies roll up. Versus can you have the entire wide area network hosted from the cloud? Probably again software defined WAN. The other interesting thing that we see in telco world, because Juniper being we have roots in telecom world, we are seeing a distributed compute model is emerging. That can I keep distributed data centers nearby, closer to the customer, which will actually, some of this IoT infrastructure will actually demand that kind of a compute infrastructure in the telecom world. And we are seeing that getting dispensed. I've seen a lot of real RFPs getting floated that can I have distributed cloud infrastructure across my POPs and getting closer to the businesses and to the end users. At the same time, what we are also seeing is this an interesting chart on the Moore's law, because we have been living Moore's law. Intel, it's actually defined by Intel founder, is that the number of transistors in a given area will double every year, every 12 months. Therefore, the cost of that semiconductor will come by half. But that is kind of becoming stagnant now, that you don't see that CPUs coming out every year with twice the clock speed and twice the performance. It is kind of plateauing until probably, unless human wisdom will, we will kind of invent a new semiconductor material which can really take you to the next top. We don't know. I mean, our knowledge is so comprehensive that the collective wisdom can build some other material. But today, as far as we see, it is kind of plateauing. That means the only way to really catch up with the Moore's law is to embrace automation. That means you need to, in server world, you're very clear. In big data analytics, what do? You actually use CPU power of hundreds of CPUs put together on a software mechanism, so that you can do parallel processing. Same thing will apply to networks as well, because networks and your security devices will also need to travel that path, because we don't have infinite CPU capability. That means we need to have certain things hosted in cloud. You have to access intelligence or big data analytics in the security domain for real-time analysis and reporting. So what is really happening in the security world? Threat sophistication is one vector. We are seeing zero-day attacks, which is a familiar one. I think many of us, I think that is the unknown attack, we call it. Actually, when the attack happens, it's like a new disease that no one has diagnosed, or no one has any symptom of. Therefore, I can't give an antivirus vaccine for that. It's as good as that. So how do we really figure out? The doctor will actually look at the posture, the symptoms, and things like that, and he start treating against it. So that is the way. I mean, it's exactly the same parallel. The cyber doctors or the researchers will do how the malware behave. Is there a behavioral thing? Is there a traffic pattern change? Is there a historical background? And those kind of things they will analyze and come up with some kind of judgment that there is something which is not normal, which need to be taken care of. Advanced persistent threats, adaptive malware. Adaptive malware is another big thing, because a malware which is being pushed into the network, it may not remain exactly the same binary. It can morph, or we call it polymorphic malphase. It can morph itself into different forms, explode into different forms and shapes that no single signature or verification algorithm can really see it. Again, cloud is adding to it. Virtualization and SDN is adding, because we are harnessing too many network components in the network, which is also touching many angles, especially your workloads. Maybe your application is same, but your workload is hosted in many server entities, many compute entities. Your assets are stored in several storage arrays. So that means you don't have a physical perimeter, so to speak, to protect, because it is so distributed and so diverse. Applications and data management, the cloud, application proliferation, infrastructure, hybrid cloud, BYOD, IoT, and things like that. All these are kind of, of course, we have great business use cases for all this. We can't ignore it. But at the same time, the hackers make use of some of these newer technologies, which I would say not mature enough. There are several instances of building automation system getting hacked, or I think Parag was mentioning about a transport system getting hacked. So these are all possibilities, and over a period of time, there will be awareness and maturity in that area. And this is the Verizon report, 58 seconds, the malware polymorph into a different kind of a code base. 89% of the attacks are with the financial intent, with some kind of economic benefit. And 50% of the attacks, even after 10 to 100 days of the threat being published, the real spoil take place after that. So these are some data points that you see. This is also important, the hacker economy. Just like we have the civil economy, morning we are having a roundtable chat. Just like we have the civil economy where the financial system, the world financial system work, the underground, the actors have their own way of running this malware ecosystem. And they have a good command and chain of control, and they have ways in which the money can be transacted and given to the beneficiary. And it's a very interesting thing. You find the report in our, or the RAND website, or in our Juniper website, with a joint study that we did, just to understand, because it's most of the time it's not a technology challenge. It is like, how can we plug the whole thing in at the root level? Just like the demonetization, it's not that the currency itself is bad. It is like, how can you really kill the root? I think, so this will give you an understanding of how well oiled the system is progressing. And of course, the attack sophistication is increasing. Evasive malwares are on the rise. At the same time, if you look at the firewall transformation, I think all of you are familiar with the firewall. The firewall transformation is started with the 5-tuple firewall to a user NG, or next-gen firewall with Active Directory integration, to now the firewalls, most of them are capable of really managing advanced threats. And what I'm seeing is that earlier an appliance is an appliance. You normally do a software upgrade maybe every 6 months, 1 year, or some vulnerability which is, or some signatures need to be downloaded. Versus, can I have a dynamic intelligence exchange? Because firewall become your most intelligent gatekeeper for you. And at the same time, it doesn't have all the CPU power to analyze all the information. It's like a security guard standing at the gate. Even if it's is 200-pound guy, his information is limited to what he sees under his nose, right? Unless somebody gives him an information that there is something in the waiting, it's happening elsewhere. The same happens to the firewall. How much ever powerful it is, how much ever great CPU it runs, how much of connection per second it runs, it's only as good as the intelligence and the policy which is defined within that. So the industry is looking at, can we elevate that policy to more of a larger global policy with the multiple track points, not just your own judgment, but maybe third-party judgments, third-party policy controls, etc., can be all mined. That's what it brings up the discussion of big data. Can the intelligence be mined, and then actionable command can be given to your network devices? So I want to propose a model called the zero trust model, because in the morning when we were discussing, one of the discussion points was sometimes the weakest link is your local area network. Because normally we trust the local area network, and that is the breeding ground for all the malwares to laterally distribute itself. Because that's what the first thing the malware do is that once they get planted, they try to distribute automatically to similar entities within your local area network, because there is no security within the local area network. That is why in data centers you see concepts like microsegmentation, so that even if one tenant is affected, it will not affect the other tenants who are hosted in a public environment. So zero trust model is all about, let's say, in here a malware got into the network either through a malicious actor or a compromised system, a mobile phone or a Wi-Fi network or whatever. It could actually get laterally distributed within the network. It's got a very limited visibility. It's very difficult to control. If you have a 1,000 node network, and it's very difficult to really scan and control mirror ports and understand the transactions. A zero trust model is that if a malware happened to infect one device, we will actually move into a place where a software defined secure network, the machine should be within almost in real time to be isolated, so that it has no way to propagate itself to the network. So we are actually harnessing the capability of the network to mitigate the risk. In service provider world, and they do it for a living to ensure that their network is not compromised. All our service providers will concur that they are hit with a lot of denial of service attacks, because their precious bandwidth, gateway bandwidth is being they cannot monetize the entire bandwidth because of so much of spurious traffic which is coming in the form of denial of service attack. This is a method wherein which you are, if you look at the building blocks of your network, you have firewalls, you have network switches, your Wi-Fi devices, your network admission control devices. You may have antivirus. So if you like all those ecosystems, can we all bring them into a single policy domain? In the earlier case, if you wind back a year, 2 years back, the firewall policies are one set of policies. Your network admission control will have a set of another policies. Your antivirus will have certain other definitions. Your switch access list is a completely a different thing. It's a different domain. Network IT expert is not a security expert. The security guy doesn't know the network. I think that need to change. If you have to create a zero trust model, this whole ecosystem has to look like a single pane of glass, and then a single policy engine with cloud-based intelligence, which can actually really program a network to the endpoint. So an uncoordinated firewall-focused orchestrated holistic system, basically harnessing the power of network. Basically, policy detection and enforcement, three very familiar terms in the standard way to understand. A set of policies, detection, and enforcement points become your network. In the traditional sense, the enforcement point is only a firewall. You put a policy and the firewall drops it. How can we enhance that system to isolate the device within your network by the policy enforcement points? Any network element within your device become a policy enforcement point. And it is like you have 5 perimeter gates in your factory, and can it all be controlled through one intelligence and all gates can be closed together, or you have to make 5 different calls to the security guard on a different times to close those gates, versus a single command to close all of them, and that intelligence is being, you've done due diligence with that intelligence. So the technology that we use is called a SKY ATP, Advanced Threat Protection. SKY ATP, of course, the SKY suggests it is in the cloud. But for data sovereignty related constraints, we have several instances of this, because it does a lot of things. One is it's got a supervised machine learning, because without machine learning, it's very difficult to figure out a heuristic based indicator. So we need to have machine learning of network components. It needs to have analysis, third-party intelligence, cloud-based sandboxing, because some of many cases the malwares come into your system through downloaded files. Of course, there are checks and balances. Some certain files cannot be opened, but bulk of it in the public domain, you could actually do the sandboxing with deception. So what Juniper adds to sandboxing is deception. What we know is typically once a malware gets into your system, it remains inactive for around 200 plus days, inactive. So that means a virus has come into your body, but it's not really giving any symptom for a doctor to diagnose. But it will come up someday when some certain vitals change. So We have a mechanism an algorithm to deceive the malware to show up, because they will look at several things, maybe a financial transaction, or going to a bank site, or create a synthetic FTP or a file transfer protocol, or create some kind of maybe an artificial sandbox, so that the malwares normally don't wake up. So we create all kinds of platforms. You create a Windows type of thing, a virtual machine, spin up a virtual machine, and things like that. So that this malware will try to tag along and distribute horizontally. So we do a deception technique and sandboxing all on ATP. These are actually licenses applied to the firewall technology. What it changes is hardware defined to software defined. So the whole thing is all about the software defined secure networks. How can we use SDN as a technology to harness the power of network and security and your policies together as a single pane of glass? That's the whole discussion. Of course, this is the kill chain of the malware. If you can, the earlier you can break this kill chain, the better you will be. And that is why you need deception techniques. You need several other heuristic technologies to break the kill chain, so that the malware doesn't really finally do the data exfiltration. Some architectural view quickly. This is how the system will work. It may look complex, but to a network, people who design network, it may not be that complex. These are actually the perimeter firewalls that you see here. SAARC is a Juniper brand. It could be some other firewall brand. And then there is an on-prem policy engine, and then there is a cloud-based policy engine. I think we can actually mine information from both. And the beauty is that once your sandboxing or your cloud broker parameters are met, or indicators of compromise is being checked against well-known data, which is well-known data is not static. The problem until now was our data was static, whether whitelist or blacklist. These are static data. Now we are moving into a cloud-based analytics that by minute there are so much of information is available in the world, either through syslog or from independent agencies like CERT and people like that. They will send a lot of feeds. The question is, can we mine those feeds and come up with actionable intelligence? And thereby this engine will actually translate that into executable commands to really do enforcement at the device level. Some deployment scenarios quickly: campus and branch, data center, or service provider networks. There are use cases for that. I'll quickly go through campus and branch. Let's say there is a system is isolated. It will actually go into the software-defined secure network policy engine. The policy engine checks certain hashes against the industrial, the cloud-based intelligence, which has got, Juniper has built a big data center within the cloud, but it has got feeds coming in from our competitors and from various other industry feeds. And we come up with a decision to block, and within probably 30 to 40 seconds, you can actually block a device which is compromised. This is micro segmentation I spoke about. This is what in the virtualized world, it's very difficult to go and put a policy per physical device. Rather you will actually do it at if it's a kind of virtualized VNI level or a VLAN level, or at a host level, or maybe at even a MAC level. So those level of segmentation is possible. You will need a virtual instance of a firewall. We have hosted this in Amazon. If you are hosting some workloads in Amazon, you can just drag and drop one firewall instance to do the micro-segmentation and security right there. Quickly on the cloud-based solution, this is a software-defined WAN I spoke about. If you are working on any branch solutions, I'll be interested to talk to you, because the branch solution is completely radically changing from the traditional way of connecting over MPLS. That's a whole world of difference in introducing security and cloud intelligence while building your wide area networks. The new term is called application-based routing. The routing is no more based on a routing protocol. It is based on your application performance. We have a series of around 500 plus application signatures, which will allow you to route the traffic based on the portfolio. I think there is right from the smallest to the biggest. I'll not go much into that. So just a couple of slides on our alliance partners, because the security is not complete. I don't think a single vendor can manage all the elements of this security. So we have actually on the CASB side, which is the cloud broker, Netscope, Cypher Cloud, Access Security, ForceCloud, and Aruba, and the Juniper Pulse Secure, the three elements there. and endpoint security carbon black. And there are APIs exposed that we can actually integrate. The question is the software-defined SDSN policy server, can it integrate to various functions within and then come up with a single policy domain? That's what it does. So these are all, there are playbooks on each of these technology areas, demonstrations available, and which is shipping now. So these are some examples of what in Netscope, CASB, what we can do in terms of it checks the incident vector along with the SkyATP, and then it comes up with a actionable intelligence. This is on the BYOD and guest access. I think with the ClearPass, Aruba ClearPass. I think that's one of the. We have several install bases, whether Aruba ClearPass and Juniper policy server working together to have third-party integration. You have switches from brand A, brand B, brand C, or firewalls from several brands, and then you can actually bring all of them together under one umbrella, wireless and wired domain. Access policy enforcement, again, just wanted to show you, we can give more details later on, but I think these are some practical use cases where you will actually deploy for the new digitized networks. So our security vision is a simplified policy and adaptive security solution and cost-effective detection and enforcement. The key thing is, can we use the SDN concept, software-defined concept, and harness the power of network and the cloud intelligence to really mitigate a zero-day attack. I think that is the whole. And finally, to run a kind of a autonomic network that we call the self-learning networks, because the network is the underlying factor to all this connectivity. So can we do an autonomic networking? So that is what Juniper is pioneering.